beta? Bunny. You're from which school? AP Junior. Okay. So you stay somewhere here close, that's why you don't come.
Yeah.
Where do you stay?
I live in Open and the Sector 20.
Sector 20. Okay. School has started?
Yes.
What is the chapter they're doing?
Numbers.
Number system. Fine. We start with number system.
Yeah.
So number system, the first type of numbers that you learn. How much of the number system they finished? When did school start?
Yesterday.
Oh, yesterday only. Fine. We start from the basics. The first type of numbers that you learned when you were small, natural numbers. Set of natural numbers denoted by capital N. The second type of numbers that you learned, whole numbers. Yes. Start with 0 to infinity. The third type of numbers that you learned are integers. Z or I, both. You can either use Z or you can use I. Some places you will see capital I, some places you will see Z. Okay. Then you learn something called as fractions. Now there are positive or negative fractions. And again, there are three types of fractions here. One is a proper fraction. What's a proper fraction? Numerator less than denominator. Example 3/4. Then you learned improper fractions. Is greater than 13/2, 7/4. All these are examples of improper fractions. And an improper fraction can be converted into a mixed fraction by writing into the integer and a proper fraction. Right? Is 0 a fraction? Is 0 a fraction?
Yes, but when it's
No, see, don't give me buts and ifs. I'm asking you, is 0 a fraction? You're telling me yes or no?
Yes.
How?
I'll make your like 0.1 to the
Beautiful, very good. Is 1 a fraction?
Yes.
Yes, by the same logic. So actually all numbers are fractions.
Yeah.
Only thing is, if I'm calling a natural number, a whole number, or an integer a fraction, means I'm speaking about those numbers with denominator 1. Do you understand? Very good. Then after that, what we learned was decimal representation of a fraction or of a number. Because as we said, all these numbers are fractions. So I'm saying decimal representation of a fraction. Again here, there are three types. One is terminating. It comes to an end. 6.23. It has come to an end. Terminating type of a decimal representation. 0.823, 817432. Yes, it took a long time, but it has come to an end. It has terminated. So this is called as a terminating type of a decimal representation. Second type, non-terminating. Recurring.
Not terminate.
6.222222 dot. When I see these dots means they are non-terminating. So this I can write like this 6.2 dot. That means the digit. This implies that this digit 2 is repeating again and again. Or 13.275.275 dot. I can see that these three digits are repeating again and again. That same pattern is being repeated again and again. So I can write this like this: 13.275 bar. This bar implies that these three digits are repeating again and again. I can put a bar here also or a dot, but because it's a single number, I'm putting a dot. I can put a bar there also, not an issue.
But we can also write it as 6.22, right?
Which one?
The 6.
No, no. If that only a single digit is repeating again and again, you will write it as 6.2 only. Did you understand? All these.
Suppose we are given a number like 3.12112111.
Correct. Very good. 3 point. Right?
Yeah. So how would we write that?
Non-terminating, non-recurring. You know why? Because that same pattern, what were the two digits here?
1, 2.
But it became 112 here. It became 1112 here. No. It has to repeat in the same manner, not like this. Did you understand? All these numbers. Yes. They are denoted by a capital Q. Capital Q implies rational numbers. What does Q include? All natural numbers, whole numbers, integers, all fractions, decimal terminating, and decimal non-terminating but recurring. Do you understand? And then we have this type, non-terminating, non-recurring, NTNR 6.23578217 dot. No particular pattern, no particular digit is being repeated. Or you have something like √2, √3, cube root of 4, fifth root of 8. All these are called as irrational numbers, and they are denoted by Q dash. Is this clear? And together they are denoted as real numbers. That means real numbers is rational numbers and irrational numbers. Some real numbers are rational, some real numbers are irrational. No rational number is irrational. No irrational number can be rational. Do you understand? Okay. Take this down as it is. Huh. Sorry? Remove the mask, I cannot hear you.
We have written our rational, sorry, real number q plus q
Dash. Q dash denotes irrational numbers. I've written that in green. You just see about that. Q dash. Yes or no?
Yes.
So Q, whenever you see the capital letter Q, it implies rational numbers. If you see Q dash, it implies irrational numbers. Unsolved exercise 1.1. You go to volume. Yeah, we'll take open. Now the definition of a rational number, if you see the textbook, what it says, what is a rational number? It is any number which can be expressed in the form of P by Q, where P and Q belong to integers and Q should not be equal to 0. Is this clear? That's a textbook definition. That means every number which can be written in the form of P by Q is as a fraction. But the denominator should not be 0. Numerator can be 0. And that is your first question. If I had asked you earlier, is 0 a rational number?
Yes.
Yes. Can you write it in the form of P by Q? Yes. 0.1 over. Understood. Now, coming to the next question, find 6 rational numbers between 3 and 4. I will show you one of the methods. There are many methods of doing it. But I will show you the textbook method, which is expected of you in the school. If your teacher allows you to use some different method, use it. Otherwise, I'll show you the standard method. I want 6 rational numbers between 3 and 4. Watch this. 3, 1, 2, 3, 4, 5, 6, 4. Now, you could have written like this 3.1, 3.2, 3.3, 3.4. But if your school teacher allows you, do it. But this won't fetch you marks in the board exam, which you'll be writing next year, that you require to do it in the standard manner. So here we consider this as A and we consider this as B. Any number in between these two can be found by using the formula A plus B by 2. Supposing I say you have got 20 marks in the exam, I have got 15 marks, right? Now, if I want to take the average of our marks, I'll do 20 plus 15 divided by 2. That will be 35 divided by 2. 35 divided by 2 is 17.5, which comes between 15 and 20. Therefore, we use this method of A plus B by 2. It's a lengthy method, but no choice. Watch. So I start. 3 plus 4 by 2, 7 by 2. I can write it as 3.5. Yes or no? But here I have isn't a 7 by 2. Now the next one. 7 by 2 plus. Now this becomes your A, that becomes your B. 4 by 2. I take the LCM, so it becomes 7 plus 8 by 4, which is 15 by 4. Now this is your A, that is your B. 15 by 4 plus 4 by 2. That is 15 plus 16 by 4 by 2. That is 31 by 8. Now 31 by 8 plus 4 by 2. That is 31 plus 32 by 8 by 2, 63 by 16. 63 by 16 plus 4 by 2. That is 63 plus 64 by 16 by 2. That is 127 by 32. So I write this. 127 by 32. 127 by 32 plus 4 by 2. That is 127 plus 128 by 32 by 2. That is 255 by 64. So this is what you have done. I repeat again. your teacher allows you to use the other method or
She
writing?
has used the other method in our school. Second question.
Acha, okay. She has used it. Okay. Fine.
But I can also ask her about this.
No. If she has asked you to do it by this method, do it.
This is the easier.
Don't troubles you. By telling her, she will go and do what you want. I showed you the easy method, why don't you use the easy method? So you can use the easy method, no problem. Understood? So if she has used that method, then you can do sum number 2, 3, 5. Do all the questions in that first exercise, right? So you can do it. Understood? First answer, start doing it. I'm happy that she's used this method. Because it doesn't make sense to waste your time on this. Why trouble yourself?
Yes. Sir, I have another book where I have written like the teacher has given us specific notes, but I have written my own notes and I have written the same thing, but I haven't got that note. So I write it in a pen book.
No, that's up to you.
So should I start with the first one or can I
Start with the first one, right? The first one we discussed. No?
Yeah, first and second.
What's the last question?
Find 10 rational numbers between -1/9 and 4/9.
So simple.
You will have to multiply.
That's the easiest thing to do. Yes.
But this is minus and you want this.
Doesn't matter. Doesn't matter. See, when you were small, when you had to compare two numbers, what was the first thing you were doing? You were making the denominator same,
Yes.
and then you were comparing the numerators. In the same manner, now you've got -10 by 90, and the other number is 40 by 90. So see, there are so many numbers: -9 by 90, -8 by 90, -7 by 90, -6 by 90, -5, -4. I'm not writing same already. -3, -2, -1, then 0.
Yeah.
Then 1 by 90, 2 by 90, right up to 39. Why 10? It doesn't have to be 35, 40.
Yes.
You understand?
Yeah.
So it does not matter. It's like a number line. On the left hand side, you've got negative numbers. On the right hand side, you've got positive
You
numbers.
should have to descend out of that and then
Go on. Yes. Acha, now it's not even necessary that you will need not descend and then go up. You can even start with 4 by 90. Look at the number line, negative numbers. 4 by 90, 5 by 90, 6 by 90, so many by 90. Not necessarily that I have to include negative numbers.
yeah. So if the question is find rational numbers between 4/9 and -1/9. So I had to start from 40/90 till -10/90.
So generally what happens is, generally we write the smaller number on the left hand side, bigger number on the right hand side. There is a person sitting in between us.
Yes.
In between us का मतलब क्या हुआ? Means you're on one side, I am on the other side. Does it specify that no, you have to be sitting here, I have to be sitting here? I'm just saying there is a person sitting in between us. That means you will sit on one side, I will sit on one side. Over. Same way, when I'm telling you to write numbers between -1 by 9 and 4 by 9, generally on the number line, where do you have negative numbers? Positive numbers. Therefore, you write -1 by 9, comma, next. Always preferably in the ascending order. Do you understand?
Yes.
You have to write you didn't do the third sum. Acha, see. every natural number is a whole number, but every whole number is not a natural number. A smaller tin can be put into a bigger tin.
Yes.
Bigger tin cannot be put into a smaller tin. If you look at my example that I gave you, like natural number start from 1. Is it a whole number? Yes. 2,
Yes.
3, 4.
Yes.
So every natural number is a whole number. You have to get the opposite. Understood? Every rational number is a whole number. False. So I'm giving you a rational number 3 by 5. Is it a whole number? Again you took it. Every whole number is a rational number. Not the other way around. Understood? Good. Now do this one also, homework questions. Okay? Go slow with the true or false because it's basically the understanding of English more than maths. Understood? Like it's like saying that can I put a small pen into a big pen? Something like that. What did he say? Did he say big into small or small into big? That. Understood? Now you got the proof also. Okay. Now, plotting or locating numbers on the number line. Do you know how to do this?
Yes,
With a compass?
We were taught, we did it today,
Ah,
and I couldn't find
root 7. Okay. I'll do it for you and show to you. You have a compass?
yes. So, check. Yeah,
And a scale
yes.
and a protractor. Scale. Sure. Oh, sorry. Now see here what I'm doing now. First of all, where will root 7 lie? What is root 4? 2. What is root? Root 4 is 2.
Yeah.
What is root 9?
Right.
3. So we have got root 4, which is 2.
So, like between human.
Beautiful. I have to take these equal distances. 0, 1, 2, 3. Now I know it lies between 2 and 3. And a compass. So I will consider my 2 to be my 0 actually. Because when I make root 2, I start with 0. So I'm taking this, right? A light line. Now this was 1 unit of mine. So this also has to be 1 unit exact. Correct?
Yes. We do this with the router.
Sorry, 69, 60, 120, and then 90. I'm very shocked at that.
No, not this one. Like, we have to take 1 unit and then we have to mark here with the router. Then with the same, we have to make a 90-degree perpendicular and then we have to.
In the sense you have to take this, exact this. That is what you mean, no? Yeah, I understood.
And then mark the color. But
That's
it's
what
the same thing.
it's the same thing, but then preferably because your teachers told you, you have to do it that way.
Yes.
Do you understand?
Yes.
Now what will you do?
Now we have to make a hypothesis.
So from where do you start?
1 to, sorry, from 0 to,
ठीक है? ठीक है?
yes.
What is this? This is root 5. Now how do I justify this is root 5? I'll just show you. Supposing somebody would ask you to prove it. Your teacher asks you to prove also? Using Pythagoras theorem?
Yes.
Yes. So now see it out. This is 2 units.
Yes.
This is 1 unit. I'm calling this as A, B, C. Pen. I'll write with pencil. Now, AC squared is equal to BC squared plus AB squared, which is 2 squared plus 1 squared,
Yes.
which is 4 plus 1, which is 5. Therefore, AC is root 5.
You look at this as 2 unit because
I took unit. Yeah, 1 unit. This was my 1 unit. 1 unit, 1 unit, 1 unit. I'm taking it as 1 inch. I can take 1 unit as 3 centimeters also, 5 centimeters also, up to me. But if I'm taking here 3 centimeters, then every number should be at a distance of 3 centimeters. And then this also should be 3 centimeters. The same unit. So now I know that this is root 5 which I plotted here. Again a perpendicular here.
Yes. We have to take a hypotenuse again from 0.
This was this much.
Yeah.
Now I will take this hypotenuse from 0. I'm calling this as point D and I'm calling this as point E. Now what is CE? CE is root 5.
Yes.
And what is DE? 1.
Yes.
Correct? Again, I'm proving it to you that what I'm going to drop here. So from here,
Root 6.
beautiful. So this is root 5 beta. This is root 6. I'm calling it as F. Now, if I want to prove, I will say CD squared is equal to DE squared plus CE squared. Pythagoras theorem. What is DE? 1 squared, root 5 squared, 1 plus 5. Do you understand?
But I haven't only the DE and you took similarly. I didn't get it exactly.
Which is the right triangle here? DEC.
Yeah.
So in that, which is the hypotenuse? CD. What is your perpendicular? DE. 1. How much is CE? Root 5. Root 5. 2 was from C to B only. Now I just plotted E. I made a new triangle. Are you getting it? Now, the last step. One more perpendicular.
Yes.
Same procedure. Right? This has to be 1 unit exact. So I'm calling it as G. Now, FG is 1 and CF is root 6. Then from 0, this is my root 7. Because my FB or FG, what is FG? 1 and CF root 6. So now I have made the hypotenuse. This is my third hypotenuse. I'm saying CG squared is equal to FG squared plus CF squared, which is root 6 squared plus 1 squared. 6 plus 1, that is 7. Therefore, CG is root 7. Don't you got it? So, supposing I tell you plot root 10 on the number line. Beautiful. And 3 is root 9. So just 1. Ah, understood?
Yes.
So what's difficult? Nothing. How will you show 2 plus root 3 on the number line?
And have
2 plus root 3. What 4 plus 3? 2 plus root 3. I give you any idea? You know how to make root 3? Root 3 you know, no?
Yeah.
Root 2 and root 3, right?
It's an irrational.
Irrational. Watch this, huh? Watch this now. I'm showing you here. Root 3 will come between
1 to, sorry, 0 to 1.
the 0 and 1. Okay. Oh, sorry, between 1 and 2, no? Root 3. Root 3 is greater than root 1. It will come between 1 and 2. Root 3 is less than root 4. What is root 4? 2. So root 3 will come between 1 and 2. So I am making this perpendicular here, bache. What happened?
Over here, I have written this one when I was finding.
Yeah. So it is, this is 0 to 1, and from there to be 1 to 2. 1 was here, no? This was the first one, no? Actually, you are not made it. It will show 1 and 2 will be somewhere here.
Yes, sir. I have written it here.
Ah.
And I have written this one. So,
Understood?
yes.
Now see, first I am making root 2, okay?
So I like the hypotenuse and then
Yeah.
mark it as
This is root 2. Just watch out. This is root 2. Again, beta. Here I am making a perpendicular. Again with the rounder, actually you will do it. I am doing shortcut. So this was your root 2. I have located root 3. But now I want 2 plus root 3. Watch what I am doing. This is 1. This is 1 unit. Yes or no?
Yes. So the second unit.
1 unit. 2 units. This is your 2 plus root 3. Because 2 units. So 1 unit plus 1 unit. 2 unit. This is your 2 plus root 3. If I wanted 3 plus root 3, I would make.
3,
4. The first thing is make the irrational number.
Yeah.
Then adding rational numbers is so easy.
Yes.
Did you understand?
Yes.
Clear?
So this will be 3 and this will be 4, right?
No. 3 will be somewhere here. See now. 3 actually would have been here. 4 would have been here. So this is coming somewhere in between 3 and 4.
Okay.
Do you understand?
Yes.
This is coming somewhere in between 3 and 4.
Okay.
Because I'll just explain to you. 2. What is the value of root 3 actually? It is 1.732. You will learn later on when you do the division. So this is 3.732.
Yes.
Which comes between 3 and 4. Logic. I'll give you the logic of it. Understood?
Yes.
More of this next time maybe. Some more sums of this time. Where I'll teach you the minus. Suppose you get minus and what? Okay. This is clear?
Yes.
So we'll stop now. Okay, bye.
Thanks.
Bye.
विकास हे एसी बंद करा आणि हे कॉम्प्युटर एसी